Hello, my name is Eugene. Today I will show you how to build your first Vara application. We will cover the whole process of building the Vara dApp, starting from the contract side. Then, we will connect the front-end side and learn the structure and all the libraries we need to prepare our application for deployment. We will start with an easy and simple application example. It's basically a counter app, but it is crucial to understand how messaging works, what tools we should use for deploying contracts, and how to act from the front-end part. Let's start. First, we prepared our example. Let me show you. This is our example. We just copy our link, go to the terminal, and clone our project. Start by opening it with our VS Code file. Open the workshop's simple counter tutorial. First, let's see our contract. This is a standard Rust program. As we can see in the cargo.toml, it's our package manager. We can see the dependencies we are using here: gmeta, gtest, gstd. gstd is a gear library for building smart contracts. gtest is a library for testing smart contracts. gmeta is a tool to generate metadata. ANS WASM Builder serves to optimize our compiled WASM file. If we were using more complex types, we would also use parity scale codec, but in this example, we are not using it. Let's check our source path. Here we can see our smart contract example. This is a simple counter. First, we see our imported modules, crates. We should pay attention to message, method. Next, we define our state, and let's talk about required entry points. First, the init function. The init function processes all code once when we initialize our smart contract in the network. The next required function is handle. In handle, we process all messages during the program's lifecycle. Everything that comes to the program will be processed here. We use message trade, load our message, and decode it with the load method. If the message matches our logic, we just increment a counter with +1. That's all. With messages, we can also reply from the network, like emitting a reply event. The last important thing is our UI's state function, state. This free view function returns the whole state of our program. We provided examples of how tests work if you are interested, but I will delete this part of the code. Let's check how to build the smart contract. I open the terminal and type this command. Everything we operate here is with the Cargo package manager. Cargo, build, flag release. Just wait, and then our smart contract will be built. It could take some time. Our smart contract is already built, and we can check our target. The path stays in target WASM 32 unknown release. Here we can see our target file. The WASM file is our smart contract. Next, to upload the smart contract. 1. Download the file. 2. Go to the Gear Idea portal. It's a special developer application that interacts with RPC nodes to upload programs, send messages, and read program state. 3. Connect our wallet. Gear Idea supports different wallets from the Substrate ecosystem, like Polkadot.js extension, Subwallet, Talisman, and Encrypt, etc. 4. I use the Polkadot extension. I can choose from my accounts. Here, I have a test account. In the bottom left corner, I can see the network state. I selected the Vara network testnet. If I don't have tokens for development purposes, I can press this button to request tokens. In my case, I have enough tokens. Once I stay in the Vara network, my account is already connected and I have enough balance. 5. Upload the program by selecting the file path, Workshop Simple Counter Contract Target Path, WASM32 Unknown Release, and naming it Hamster Clicker. Calculate the gas by pressing the button. Sometimes, when we initialize our program, we can send a message to process it. In this example, we don't have any message. Submit the program. It sends the transaction. Check the program status. It has an ID, is activated, and shows the creation date, code hash, metadata, and messages list. Also, we can read the program's state. Right now, it's 0. Next, we should connect our program to the front end and learn how it works. I go to the front end and install all the dependencies using Yarn. Three, open the .env file and copy the program ID, then rename it. 4. Run the application with yarn start. Okay, this is our simple counter. This is the famous hamster, as you can see. I connect my wallet the same way. Update the managed website, and now I manage wallet access. I will use my test account. And let's see, we send a message. If we click, we send a message and change our state. Let's discover how it works from the front end. For this, we provide a big batch of different hooks to help you send messages and read the state. We can find the metadata file that we use to encode and decode messages and state. The most important tools can be found in Source, App, Hooks, API. Here you can see all the needed functions to work with metadata and program state. Also, we provided our custom function to read state and send program messages. All these functions can be used from Gear.js React hooks. Let's check our main app component. Here we also use different helpers like useAccount, useAPI. If the API is ready, we display our application. If it's not, we can show the loader. Let's try again and check the template. Our template provides API, all hooks, wallet, connection, etc. Let's send the message. Now, you can see in the code that our state was incremented to +1. Let's send the message. That's all you need to know to start building a Vara application. We will leave this link to try this example. This is just a simple example to understand the basics, how messaging works, the contract structure, which libraries to use for the front-end side, and how to work with metadata. But Vara, of course, has many more advanced capabilities. Everything you can discover in our wiki documentation and learn about how everything works, how asynchronous programming works, how gas reservation works, how messaging works, how the built-in actors work. You can see all the information described there. We have also prepared different examples, like showcases, to help you build more complex applications. You can check the Vara website for dApps examples. About 35 different smart contracts use the full range of our features, including staking, delayed messages, asynchronous interaction, and oracles. Everything you might need. Feel free to use this example in your work. So guys, thank you for watching. I hope my workshop will help you start building on Vara. If you have any questions, just use our official Telegram and Discord channels to ask our developers. Thank you. Bye-bye.